Hello. This video is the beginning video for adding. We're going to use Dean's blocks, also called base 10 blocks. They're a virtual manipulative. It can be found at mathspot.com/manipulatives/blocks. Before we look at adding, it's important to understand counting a little bit better. Before learning to add, we learn to count. We count to learn how many. I have two piles of yellow unit squares over to the left. If I put them together to make one pile, I would be adding them. How many will be in the combined pile? Even if you know how to add, why does it take effort to answer this question? Well, in order to add them, I would have to figure out how many I have in each pile first, which means that I would have to count. The numbers that we add together are called addends, and the result, the answer, is called the sum. Adding requires addends. Together, they equal the sum. In our example, we have 1, 2, 3, 4, 5, 6 over on the left, and 1, 2, 3, 4, 5, 6, 7, 8 on the right. So we have 6 plus 8 equals 14. 6 and 8 are addends, and the sum is 14. If we don't know the addends, then we can't add. In our case, we'll assume we don't know the addends, so we might as well just count all the squares directly. And that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. If we knew how many there were in each pile, we could save time by adding. What if you knew the amount for one of the piles, but not the other? So let's assume that we know that we have 6 over here. Rather than count all the squares, you could start counting the unknown pile from one more than the amount you know. So we know the 6, and this would be 7, 8, 9, 10, 11, 12, 13, 14. This is more efficient than counting all of the squares. Why bother to count these if we already know how many there are? Efficiency is generally very important in math. It is what motivates a lot of what we do in math, to find an efficient way to figure out how many. This strategy is called counting on. What if you are forgetful or unsure of an addition fact? Adding is quicker than counting, but that requires that you've memorized the fact. Well, one suggestion is to count on from the larger addend. So counting on for 6 steps from 8 is less work than counting on 8 steps from 6. So if I know this is 6 and this is 8, I would start over here and say, this is 8. I'll count on now with the smaller one. 9, 10, 11, 12, 13, 14. It's better to take a little time and get the right answer than get the wrong answer quickly. Making tens. Another strategy for adding is called making tens. Because our number system uses base 10, we carry or regroup when we reach 10. 6 plus 8 with the blocks, we exchange 10 yellow unit squares for 1 green rod. So over here, I have 8. If I could bring over just a couple, then I would have 10, and I could make an exchange, and I'd get a 10 that I could put in the tens place. We'd write a 1 in the tens place, and we'd have 4 left in the ones place. So let's do that. I'll move over 2 of these. And now I can exchange it for a 10. I'll put it over on the left since we normally have the tens place over to the left and the ones place to the right. Now we have 1 10 and 4 ones. How many more is required to make 10? Well, these pairs go together. In our case, we had 8, so we needed to take 2 away from the 6 in order to make a 10. 1 and 9 make 10, 3 and 7 make 10, 4 and 6 make 10, and 5 and 5 make 10. Once again, pretend you're unsure that 6 plus 8 is equal to 14. How many are required to make 10? 2 more. If we take those 2 from the 6, how many will be left in the pile? 4. And that's what we saw. We now have a pile of 10 that I've exchanged for a 10 and another pile of 4. Because one of the addends is a 10 and the other is a single digit, adding them is very easy. 10 plus 4 is equal to 14. And so this is an easy strategy if you forget an addition fact. Thanks for watching.